For part B, I'm going to ask, how long does it take to land? So my initial and final point for this question is going to be here where it launches. That's my initial point. And I want to know, how long does it take to get to this final point, the landing point? Now I can use some information that's going to make my life a little bit easier. In the y direction between launch and landing, my vertical displacement is 0. So if I look in the y direction again, we'll go down to part B. If I look in the y direction again, but this time I'm only interested in the points between launch and landing, I know my initial y velocity. That one is still 29.1246 meters per second. I know that the displacement between launch and landing is 0. I know my acceleration is still 9.81 meters per second squared down, and this time I would like to find delta t. So in this case, the equation that I'm going to end up using to put all of this together is this one. So now I can take a look at this equation. I know delta dy is 0, so already I'm not going to have to solve a quadratic equation, or well, at least an easily factorable one. v1y is 29.1246 times delta t plus 1/2 negative 9.81 delta t squared. So this equation is completely describing the motion of this projectile. But I get to interpret what the math means. So if this were any old quadratic and I wanted to factor it, I would factor out a delta t. So I'd get 29.1246 subtract 4.905 times delta t. So if this were any old quadratic equation, you would say, okay, what are the roots of this particular equation? In order for the right-hand side of the equation to equal 0, either delta t has to equal 0 seconds, or this side of the equation has to equal 0. So 29.1246 subtract 4.905 delta t has to equal 0. Some quick rearranging tells me that delta t is equal to 29.1246 over 4.905, which gives me a delta t of 5.9377 seconds, rounded to 3 decimal places. So what do those two numbers mean? Well, if we look back to our actual trajectory, we just asked that equation, at what 2 points in time is the displacement of the ball in the vertical direction 0? Just by looking at that equation, we know it's this point when time equals 0, and this point when time is something greater than 0. Going back to the roots of our equation, we therefore know, based on our interpretation, this point is inadmissible to the problem. It's telling us that at time equals 0, the ball is at 0 vertical displacement, obviously. This is the answer we're interested in. So therefore, the ball is in the air for 5.94 seconds.